Jupiter is nothing like the planet you grew up imagining. Almost everything we were taught about it turned out to be incomplete or outright wrong. This isn't a simple ball of swirling gas. Jupiter is a world of liquid, strange, extreme, metallic liquids unlike anything found naturally on Earth. Beneath those familiar striped clouds lies one of the most bewildering structures in the entire solar system. So let's go beneath the surface. The first close-up photo of Jupiter was taken by Pioneer 11 in 1974. A few years later, Voyager 1 captured the first moving images, hypnotic streaks of storms sliding across its massive face. But as breathtaking as these early views were, they didn't answer the fundamental questions. What is this planet actually made of? And how did it grow to be so impossibly large? To grasp Jupiter's scale, imagine the Earth as a grape. Jupiter would be a basketball. It's so massive that it outweighs all the other planets combined. More than 1,000 Earths could fit inside it, and even that comparison barely captures its true bulk. Our standard model of solar system formation begins with a swirling disk of dust, rock, gas, and ice surrounding a newborn sun. Over time, small objects collided, merged, and grew. Eventually, one of these growing worlds became large enough for its gravity to vacuum up the surrounding gas. Under that explanation, Jupiter would contain a huge, dense core of rock and metal buried under an enormous atmosphere. A different idea imagines something even stranger. That Jupiter began as a colossal gas cloud, almost like a failed star floating near the young solar system. It grew dense enough to collapse under its own gravity, forming a giant sphere of gas that was later captured by the sun's pull. In that version, Jupiter wouldn't have a traditional core at all, just endless layers of gas getting denser toward the center. The textbook story favored the solid core model, and while it sounded reasonable, it wasn't accurate. The truth didn't start to emerge until the mid-1990s, thanks to an extraordinary coincidence. In July 1995, Jupiter was struck by a comet, a once-in-millennia event. The comet, Shoemaker Levy 9, had broken into dozens of fragments, the largest about 2 kilometers wide. Moving at over 216,000 kilometers per hour, Hubble was ready to observe, but the fragments were going to hit on the far side, hidden from Earth. And then came the miracle. At the same moment, NASA's Galileo spacecraft was arriving at Jupiter after a 6-year journey. It had a perfect view. Over 6 days, Galileo watched 21 violent impacts, each one releasing energy on a scale humanity had never witnessed. One strike alone equaled hundreds of millions of atomic bombs. When Jupiter rotated, Hubble finally saw the aftermath. Dark scars the size of Earth, towering plumes of debris, and atmospheric shockwaves that lingered for months. Galileo flew through the fallout and detected something shocking: large amounts of water. That discovery was strange enough to fuel the next big mission to Jupiter Juno. Launched in 2011 and arriving in 2016, Juno finally revealed what was really hiding beneath Jupiter's clouds. And this is where everything changes. The gas giant isn't made of gas at all, not in the way we imagine. Jupiter's iconic clouds are a thin outer shell, only about 50 kilometers deep. Within them, temperatures fall below -100 degrees Celsius. Ammonia mixes with water ice to form a bizarre antifreeze slurry. Droplets collide with ice crystals, building electrical charge until giant lightning storms erupt, storms so massive they dwarf entire continents on Earth. These violent systems drive towering plumes that reach deep into the atmosphere. The Great Red Spot, wider than 2 Earths, is one of these titanic structures, a storm extending hundreds of kilometers downward. Its crimson color comes from chemicals stirred high above the clouds, reacting with harsh ultraviolet sunlight. But all of this chaos is just the thin skin of Jupiter. Below the clouds, pressure skyrockets. Gravity compresses the atmosphere so intensely that hydrogen gas begins changing phase. About 1,000 kilometers down, hydrogen transforms into a liquid, the largest ocean in the solar system. This ocean isn't water. It's a superheated, incredibly dense sea of liquid hydrogen, thousands of degrees hot, held together only because Jupiter's gravity raises the boiling point far beyond anything seen on Earth. This ocean stretches about 20,000 kilometers deep, and below that, things become even stranger. At crushing pressures millions of times stronger than Earth's surface and temperatures near 10 degrees Celsius, hydrogen undergoes another transformation. It becomes metallic, a shimmering, conductive liquid capable of carrying electricity. In this metallic sea 40,000 kilometers, deep electrons flow freely, generating Jupiter's immense magnetic field, the strongest youngest of any planet in the solar system. Beneath this metallic layer lies Jupiter's core, but not the core scientists expected. Instead of a compact ball of rock and metal, Juno found a vast, diffuse, fuzzy core, an enormous, blended region where rock, metal, and metallic hydrogen mix together with no clear boundary. It spans nearly half the planet's diameter. The solid material seems diluted, as if something once smashed through Jupiter's center and stirred it up. One theory proposes that in the early solar system, a planet perhaps 10 times the mass of Earth collided with young Jupiter, disrupting its interior and creating this strange, semi-liquid core. But simulations show that such a core should eventually re-solidify, yet Jupiter's hasn't, so something is missing from our understanding. Even now, after decades of missions, we still don't fully know how Jupiter formed or why its interior behaves this way. It defies our expectations at every turn, and that's what makes Jupiter fascinating. It's not just a giant planet, it's a colossal enigma, a natural laboratory of physics pushed to the absolute limit. A world of liquid metals, impossible oceans, nuclear-scale storms, and a history that still refuses to reveal itself. If you enjoy exploring mysteries like this, consider subscribing to the channel. There are countless more wonders waiting to be uncovered. And we're just getting started.